In today's lesson, we are going to talk about the properties of logarithms. And we know that y equals log base a of x. You've got the exponent, the base, and the argument. And to change in from logarithmic to exponential, base to the exponent equals the argument. Just keep that in mind. So we have three properties. You can take one log and expand it when your argument has more than one element in it. So here I have an m and an n, and I'm going to take this one log and expand it. Since I have two letters in here, I'm going to use two logarithms, and I'm just going to keep the base the same. So when you have two elements in there and it's multiplied, so these are factors of each other, factors with each other, m plus n. In this case, when the argument is a quotient, you've got a numerator and a denominator, the m minus n. So I'm taking the part of the argument that's in the denominator, giving it its own log with a negative in front. And then, this is an excellent property. Anytime the argument is raised to a power, that power can be moved down in front as a coefficient. And log and natural log are the only functions that have this super ability. When the argument is raised to an exponent, you can move that exponent down in front if you want to. So let's expand first. So I have log base 6. My argument has an a, b, and a c. So I want each of these letters to get its own log. Now, since all of these are being multiplied, I'm going to use a sum of these logs. And according to that other property, this important one down here, I can take the exponent of the argument and move it to the front. So that 4 can be moved in front. That 3 can be moved in front, and that doesn't have an exponent. Over here in example 2, P, Q, and R. I have 3 letters, so I again am going to use 3 logs. So I'm going to start with P to the 8th, Q to the 1/2. Remember, when you have a radical, that's an exponent of 1/2. Unless it's a cube root, then you have an exponent of 1/3. Now notice the r squared is down in the bottom in the original, so we use a negative in front of the log. So I'm going to break it up into 3 logs, and then I'm just going to take the exponent down in front. Okay, 4 letters in this one, so I'm going to use 4 logs. So I'm going to start out with the T, and I'm going to bring the 7, and since that's in the numerator, that's a plus, a positive log. The S is in the denominator, so that's going to be a negative log. The V is in the denominator, that is a negative log. And the W is also in the denominator, so I have a negative in front. And I just took all of the exponents and brought them down as coefficients. Okay, just a couple more. I don't have a base here, but it really is a 10. Just remember, that's called a common log. So I have 3 logs. I'm going to combine that as 1 log with the argument on top. This argument belongs on top, and this argument belongs in the bottom of the new argument because of the negative. So I'm going to combine here 1 log base 4. So I'm going to take the 2 and bring it up as the exponent. I'm going to take the 1/2 and bring it up as the exponent. That will give me a square root of x located in the bottom, the denominator of the new answer, of the new argument. I'm going to take the 3 and bring it up as the exponent. And then that 2x minus 5 cubed will go into the denominator of the new argument. So when you're combining a number of logs into one log, you're just really amping up that argument. Okay, so expand using sums and differences. It also works with natural logs. So I'm going to use the natural log of x cubed. I'm going to use the natural log of the square root of x minus 2, putting that as 1/2, and the natural log of x plus 1 quantity squared, and notice that has a negative in front. And then just take a moment, bring the exponent down in front, exponent in front, and exponent in front. And that's expanding using sums and differences. In this problem, I'm going to show all of the steps that I could possibly use. So I'm going to take this log and change it from radical form and put it as an exponent of 1/2. And then I'm going to bring the 1/2 down in front. I could bring a 4. I can factor out the greatest common factor of 4 in this step. And then this x squared plus 4, remember, is x plus 2, x minus 2. So I have this 1/2 bracket, and then log 4 plus log x plus 2 plus log x minus 2. So I really just kind of took this one logarithm and showed all of the different forms that you could possibly see. Now memorize some different things about logarithms. When the argument is 1, no matter what the base is, log base anything of 1 is 0. Another thing, when the base and the argument are the same number, that's 1. Now, if you have a base A and log shows up in the exponent with the same base, that all cancels out and you're left with just the argument. And if you have a log base A and the exponential shows up in the argument and they're the same, you have R. So things really start canceling out when you get it a little bit more complicated. So memorize these properties. So examples of that, I have a log base pi. In the argument is an exponential expression with base pi. Everything will cancel out. 3 is my answer. I have an exponential with a logarithm in the exponent position with the same base, square root of 3. Now, we'll get more into this, but a natural log and an e are inverses of each other, and you're left with 0.35t. You can kind of think they'll cancel out. The change of base. If you don't like the base of a logarithm, you can change it into a natural log, you can change it into a common log, you can change it into a log of any base you want by saying, if a natural log, you can say ln of the argument over ln of the base, or log of the argument over log of the base. You could do any base. You could change to a log 7, log base 7 of m over log base 7 of a. So right here, log base 5 of 89 could also be written as just plain old common log of 89 over common log of 5. You can put it in your calculator and just go to town. Over here, ln, let's say you want to use your ln button. Natural log of the argument over natural log of the base. Put it in your calculator and you're done. So you can change any log to a natural log problem or a common log problem. So let's talk a little bit more about e and the natural log. E is exponential. It's a base and it wants an exponent. So what happens when the natural log shows up in the exponent? So here I have a base e, the natural log has shown up in the exponent. E and ln are inverses. 4 is your answer. E and ln are inverses. X is your answer. Same thing here. Now in these examples, You can't just cancel out the E and the ln if there's something in between them. Notice here, there's nothing in between the E and an ln. Here is a 2. But remember, ln has that super ability to take the number in front and move it up as the exponent of the argument. So I'm going to write it like this. Now, nothing in between the E and ln, x squared is your answer. Uh-oh, I've got a 1/2 standing in between the E and the ln. But ln says, hey, no problem. I can take the 1/2 in front, move it to the exponent of the argument, and then, boom, the E and the ln can cancel out, square root of x. Remember, when you have a 1/2 exponent, that's really square root of x. Now, ln is the natural logarithm, and it needs an argument. What happens when e shows up in the argument? So in this example, the ln and the e are inverses. They cancel out, 3. ln and e are inverses, they're gone. ln and e are inverses, they're gone. Pretty simple. So we can use this to solve. So I want to get rid of that e. So I'm going to take ln of both sides. The ln and the e cancel out. ln of 3 is just ln of 3, and then divide by 2. Over on this side, I want to eliminate the natural log. So I will base e both sides. Remember, e is a base. So base e both sides. The e and the ln cancel out. I have e squared on the right. I add 1 and divide by 4, and that should be, hold on, a +1. Okay, sorry about that, guys. And that is it. Okay, so good luck on your MyLabs Plus assignment, and we'll see you later.